Bismillahirrahmanirrahim. Today we have our fifth lecture of mathematics, and today we will discuss the new topic of our chapter 1, that is composition of a function. Now, what is the composition of function? We define these functions as a function. A composite function is created when one function is substituted into another function. And its example is here. We have a simple function f of x is equals to 3x plus 2 and g of x is equals to x plus 5. So here when we write in a composition form of these function, we write it like f of g of x. It means here g of x is a function which is substituted into another function. The another function is f of x. G of x is substituted in a function of f. And when we write f of g of x, we can write instead of this writing g of x, we can write its value, and its value is x plus 5. So when we write f of g of x, and in this step we have written the value of g of x, and we get f of x plus 5. Now here we have this x plus 5 behaves exactly as in the function of x, this x behaves. So when we put this x in this function, when we put this x in this function, we get 3 multiplied by this x plus 2. And same, when we put this x plus 5 in this function, we get 3 multiplied by this value x plus 5 plus 2. And when we simplify this part, we simply get 3x, 3 multiplied by x plus 3 multiplied by 5, 15 plus 2. And again, by further simplification, we get 3x plus 17. And same calculation we have done with g of f of x. Here we have taken f of x inside of this g of x, or in other words we can say we have substituted this f of x in g of x. So instead of writing here f of x, we have written here this function f of x. And what is the function of f of x? That is 3x plus 2. So g of 3x plus 2. But we know g is such type of a function in which when we substitute this x, we get x plus 5. So here we have 3x plus 2 instead of this x. So instead of x, this g add 5 in this x, which is 3x plus 2. So 3x plus 2 plus 5 gives us 3x plus 7. This is another example for describing the composition function f dot g of x, which can also written as f of g of x. And you must keep one thing in this example, that you always go from right to left. What we do, f of g of x means f of g of x. So first we have to solve this g of x. So here g of x is equals to x minus 1, means whatever in this x inside this g, whatever the value of this x inside of this g, it will subtract 1 from this value. So here we have some different examples. So when we put this 5 instead of this x, as g of x is a function which subtract 1 from this x, so g of x 5 means we subtract 5 minus 1 is equals to 4. Similarly, when we put 7, g of 7 means 7 minus 1. 7 minus 1, 6. And 3 minus 1, 2. Now 4, 6 and 2 are the values of all g of x. But still we have to apply this f on this g of x. So when we apply this f, what will happen? Simply when we put any x in this function x, in this function f, sorry, in this function f, we whenever we put any value of x, we get 2 multiplied by x. So here we have f of 4, f of 6, f of 2. So simply as the function tells us multiply 2 with x, so f of 4 means multiply by 4 with 2, we get 8. F of 6 means multiply by 2 with multiply by 6 with 2 and we get 12. F of 2 means multiply by 2 with 2 and we get 4. So in other words, these are all are the domains of g of x. These are at a time the range of g of x and the domain of f of x, and these are the range of f of x. Now these function, I will explain these function by solving some questions from your exercise. So here we start our exercise. Exercise 1 point, exercise 1.2 at page number is 14. Now question number 1. In question number 1, the real valued function f and g are defined below. Here we have two function f and g, and what we do with these function, we have to find the composition of these function. Here we have a different parts of these function, this question. The first part is f naught g of x. We have to find this, where f of x is equals to 2x plus 1 and g of x is equals to 3 divided by x minus 1 with the condition x not equals to plus 1. Okay, we start the solution of our question. F naught g of x means we can write this relation as f of g of x. These both representations are same and both are showing that these are two function and these are two function and the function is a composition function. So first, whenever we solve the composition function, the the first function, the function which have written at the outside of this brackets remains the same. First, we will solve the function which is inside of these brackets, or which comes second of this composition. F naught g of x means f will be remain same here first, and instead of this g of x we will write the value of g of x. And what is the value of g of x? Here we have g of x is equals to x minus 1. Now f of 3 divided by x minus 1. Which type of function is f of x? F of x is such type of function when we substitute x in this function f, we get x multiplied by 2 plus 1. So here we have, instead of x, we have 3 divided by x minus 1. 2 is same as here as in the original form of f of x. 2 is same, so we have written 2 here. Then here we have x, so we write x over here. So here we have 3 divided by x minus 1. So we write 3 divided by x minus 1. Then plus 1. So we write here plus 1. Now we will simplify very easily this part of the question. 2 multiplied by 3 is 6 divided by x minus 1 plus 1, And when we take an LCM, x minus 1, 6 plus 1, x minus 1. And by further simplification, we get 6 plus x minus 1 divided by x minus 1, and 5 plus x divided by x minus 1 is the answer. Now question number 2, second part. Here we have f of x is equals to under root x plus 1, and g of x is equals to 1 divided by x square with the condition x not equals to 0. Here I would like to solve g naught of f of x for this part. Now solution, g naught of f of x means g of f of x, and we use the value of f of x, which is equals to x plus 1. Now what we do here, we know that g of x is such type of a function when we substitute this x in this function g, we get 1 divided by square of this x. So consider this under root x plus 1 same as this x. Or in other words, we can say when we substitute this under root x plus 1 in this function g, this function g convert this under root x plus 1 into 1 divided by x plus 1 under root whole square, like this g of x. And we cancel this 2 with under root, and simply we get 1 divided by x plus 1 is the answer of or this part. Now the third part of this question is f of x is equals to 1 divided by under root x minus 1, where x is not equals to 1, and g of x is equals to x square plus 1 whole square. For this part, I will solve f naught f of x. F naught f of x is equals to f of x. Here we write the value of f of x, which is equals to 1 divided by x minus 1. And same, when we substitute any x in this value of f, we get 1 divided by x minus 1. But here we have 1 divided by x minus 1 in, we have substituted this 1 divided by x minus 1 under root in this f. But this f and this f are the same, and they both behave, and both have the same behavior. Like this f is also convert this value of this substituted value is in f in this f. When we substitute this value in this f, it will also convert it into 1 divided by under root x minus 1. So what we write here? We write here 1 divided by 1, this one is of the function 1 divided by 1 of under root x minus 1 minus 1 whole under root. What we have done here? Simply x minus 1 under root is the value of this f of x. F of x is equals to 1 by under root x minus 1 is the question, and we have done the same operation with this type of a function 1 divided by under root x minus 1. ये दोनों एक जैसे लग रहे हैं, बिल्कुल एक जैसे. 1 divided by x minus 1 under root original function की वैल्यू है, but we have to apply this rule on this function also. आपने इसको ये नहीं देखना है कि ये 1 डिवाइडेड बाय अंडर रूट एक्स माइनस 1 है. आपने इसको बिहेवियर इसका ऐसा होना चाहिए कि 1 डिवाइडेड बाय अंडर रूट एक्स आप यूज जरूर कर रहे हैं, लेकिन एक्चुअली ये एक्स है जो ऊपर फंक्शन में भी गिवन है. आपने क्या किया, आप इसको भूल जाए यहाँ क्या लिखा हुआ है. आपने ये लिखना है 1 डिवाइडेड बाय, यहाँ पे x था तो आपने यहाँ भी x लिख दिया. यहाँ पे 1 डिवाइडेड बाय अंडर रूट एक्स माइनस 1 है तो आपने यहाँ भी लिख दिया 1 डिवाइडेड बाय अंडर रूट एक्स माइनस 1. फिर -1, वो -1 ये लिख दिया, और फिर उस सारे फंक्शन पे अंडर रूट है तो इस सारे फंक्शन पे भी अंडर रूट है. आपने बिल्कुल एग्जैक्टली वैसा ही फंक्शन बना दिया जैसा कि f है. f का जो भी कैरेक्टरिस्टिक्स है f के, आपने वो सारे अप्लाई कर दिए अपने इस फंक्शन के ऊपर भी. ठीक है, and the rest of your calculations are very simple. 1 divided by when you take an LCM over here, what you get? Under root x minus 1 minus under root x minus 1 whole under root. ये चीज इसको कन्वर्ट कर दें. You can convert it x minus 1 under root divided by 1 minus under root x minus 1 whole under root is the answer of your question. Now the fourth part of your question. Fourth part is f of x is equals to 3x4 minus 2x square, where g of x is equals to 2 divided by under root x. For this part, I would like to solve g naught of g of x. Solution: g naught g of x is equals to g of x, and g of x is equals to 2 divided by under root x. Same rule here. When we substitute any x in this function g, we get 2 divided by under root x, under root of this substituted value. So same, when we substitute 2 divided by under root x, what we get? We get 2 divided by this substituted value. 2 divided by this substituted value, and when we simplify this we get with under root, sorry, and when we simplify this 2 divided by under root 2 divided by x under root and one more under root. Further simplification gives us under root of under root x divided by under root 2. We have converted this, and under root, we know that under root 2 is equals to simply 2. So here you can write under root 2 at the place of this 2, under root of under root x divided by under root 2. This 2 and under root 2 and under root 2 are cancelled, and we get under root 2 of under root x. This is the answer of your question. So these are the different parts of your question number 1. The second topic of your today's lecture is inverse function. Inverse function is a relation. A relation is a pairing of input and output values. What is a relation? Relation is a pairing of input and output value. Similarly, an inverse relation means that the domain and ranges are interchanges. Means if you have two functions, f and g, these are the simply f and g are the two functions and when you find the inverse of these two functions, you will interchange its domain and range. Means if the range of the domain of f becomes the range of g, and the range of f becomes the domain of g, and the graph of both functions are the reflection of each other. Or in other words, we can also explain function f and g are inverses of each other if we have discussed the composition of two functions, and these two functions are inverses of each other if f of g of x is equals to x and g of f of x is equals to x. Means if both become equal, both have same values, then we can say that the function g is written as f naught of x, which is the inverse. Means these are these two functions becomes the inverses of each other when both have same values. Now come to the formal definition. If f and g be two functions such that both have the composition of both function is equals to x, when f naught g of x, we find f naught g of x is equals to x, and when we find g naught of f of x, this is also equals to x, then we can say that g is the inverse of the function f, and the function g is denoted by f inverse, right? But the one more thing which is very important and very common mistake of students, f inverse does not means f divided by f of x, right? This is the concept. This is the concept that it's a inverse function of certain function. Now, in your course, we have to find different inverse function, and we have certain rules for finding the inverse function. The first step is I have divided the inverse function, finding the inverse function into different steps. The first step is write down, write out the function as y is equals to whatever the function is. The second step, you have swap the x and y. The third step, make y the subject. And the step 4 is instead of y, you should write f inverse of x. And I will explain these rules by this example. F of x is equals to x plus 1. Simple example. The first step is you just replace f of x with y like this. Here we have f of x is equals to x plus 1. You just replace this f of x by this y. You just write y is equals to x plus 1. Okay. Now the second step, switch x and y. Now here we have y is equals to x plus 1. You just switch x and y. Here you write x is equals to, sorry, x is equals to y plus 1. X is equals to y plus 1. At the place of x you write y, and at the place of y you write x. Okay. Now whatever you get the equation by switching x and y, you solve the new equation for y. Here we get, by switching x and y, we get x is equals to y plus 1. Now solve this equation for the value for y. So for when you solve this equation for y, you what you get? Y is equals to x minus 1, and here we have y is equals to x minus 1. And when you get y is equals to x minus 1, the fourth step is just replace y with f inverse of x. So here we have y is equals to x minus 1, and you just replace this y with f inverse of x. So f inverse is equals to x minus 1. So it's our original function, f of x is equals to x plus 1, and here we have the inverse of this function, which is equals to x minus 1. So we can say that, and when we talk about the domain and range of these two functions, when if we have f of x and the domain of f is a and the range of this f is b, but when we find the inverse of this f of x, the range of f becomes the domain of f of this function, and of this f inverse, and the domain of f is the range of f inverse. Here is the one more view of this original function and inverse of the function. X, domain x become the range of inverse function, and the domain of x becomes the range of original function. Now this is the example for original function and inverse of function and their domains and range of the functions. This is the original function, and the function is f of x is equals to under root x plus 2. And this is the inverse of this function. You can calculate this inverse function by doing the same steps. And when you get f inverse of x is equals to x minus 2, simply without doing any calculation, how you get the domain and range of these functions. This is a simple function x plus 2, and we know that in such type of a function we can use any value in this function except certain values. Its domain must start from -2 to positive infinity, and from -2 it is a closed interval. -2, if we write -2 plus 2 means we get 0, but when we take some less value from -2, what we have? Minus 2 minus 3 plus 2. Minus 3 plus 2 means you get minus 1 under root, and minus 1 under root means you have some complex values, and we avoid in when we decide our domain, we avoid the complex numbers, and all those numbers which also gives us the undefined results. So in this case, we start our domain from minus 2, from close interval to plus infinity. And domain is when we put minus 2. Minus 2 plus 2, what we get? We get 0. So this is the this is the range. I'm talking about this range. When we put minus 2 in our function, we get 0, and means our range is started from 0 up to plus infinity. When you decide the domain and range of your original function, definitely you get the domain and range of your inverse function, because the domain of your original function becomes the range of your inverse function, and the range of your original function becomes the domain of your inverse function. Now, second question of your exercise 1.2. Question number 2, in which we have to find, for the real valued function f defined below, find f inverse of x. F inverse of x, and the first part is f of x is equals to 2x plus 8. For this function, we have to find f inverse of x. Its b part is f inverse at minus 1, and we have to verify f of f inverse of x is equals to f inverse of f of x is equals to x. We have to verify this equation, and these are the two different parts, and now we will start our solution. F of x is equals to 2x plus 8, and as I have told you about the steps for finding the inverse function, so step 1 is, what was the step 1? The step 1 is we replace f of x with y. So we write y is equals to 2x plus 8. This is our first step. Okay. Now step 2. Step 2, switch x and y. Okay, we switch the x and y. So what we have? Instead of y, we write x, and instead of y, x, we write y. Now step 3. Step 2, step 3. Solve this equation for new y. Solve the equation for new y. Okay, now 2y is equals to x minus 8. And y is equals to x minus 8 divided by 2. Let me check one thing. What we have? Our question is f of x is equals to minus 2x. Here we have minus 2x plus 8. Again we have minus over here. X is equals to minus 2y. And then when we solve here we have minus, then minus 2, and when we adjust this minus 2 we get 8 minus x divided by 2. And the last step, step 4, replace y with f inverse of x. So our final result is f inverse of x is equals to 8 minus x divided by 2 is the inverse of our function. So f of x was 2 minus 2x plus 8, and f inverse of x is 8 minus x divided by 2. Okay. Now we have to find its b part. And the b part was we have to find the inverse at point minus 1. F of minus 1 of minus 1, 8 minus minus 1 divided by 2, 8 plus 2 divided by 2, 10 by 2, and answer is okay, plus 1, and the answer is 9 by 2. The answer is 9 by 2. 9 by 2 is our answer. Now the third part, in which we have to verify the equation. Verification. The equation was, which we have to verify, f of f inverse of x is equals to f inverse of f of x is equals to this x. Okay. Now f of f inverse of x is equals to, here you can write f of x is minus 2x plus 8, and f inverse of x is 8 minus x divided by 2. Okay, as we know in composition, this is the composition of two function, composition of f and f inverse. So here we write f and f inverse of x, and we solve it as we have done the composition of two function. So the f is same, and we write the value of f inverse of x, and which is equals to 8 minus x divided by 2. And similarly, we have f is equals to minus 2x plus 8. When we substitute this x in this function f, we get x multiplied by minus 2 plus 8. So 8 minus x divided by 2 is our x. So what we do? We multiply 2 with our x and add 8 in our x. Now simplify this equation. 2 will be cancelled with this 2, and we get x minus 8 plus 8 is equals to simply x. This is the first part, first equation. Now we solve f inverse of f of x is equals to x. We have to prove this. So what we do? F inverse is same, and we write f of x, and or f of x is minus 2x plus 8. Now what is the property of our function of inverse function? When we substitute any x in our inverse function, this function convert this x into 8 minus x divided by 2. Okay, 8 minus means 8 minus, instead of x, what we have? We have minus 2x plus 8 whole divided by 2. Simplify this equation. 8 plus 2x minus 64 whole divided by 2. And 8 minus, sorry, here we not multiply this, we have to just apply this minus sign inside the bracket. So what we have? Plus 2x and minus 8 divided by 2. This 8 and this 8 is cancelled with each other, and we get 2x divided by 2. Again 2 cancel, and simply we get this x. So from 1 and 2 we verify the equation, and this is the result of our first part. And by doing same calculation, you solve the rest of 3 parts. And now I'm doing question number 3 without. Now question number 3 is without finding the inverse, state the domain and range of an f inverse. Question number 3, without finding the inverse. Okay, without finding the inverse, you just state the domain and range of inverse of the function. The function is f of x is equals to under root x plus 2. I have discussed this function in my example also. So, okay, for domain of this function, we check this function on a real numbers, and for real values of f, for real values of f, x plus 2 is greater than or equals to 0. We are checking here the positive, we are checking the this function for the real numbers, for the positive real numbers. And what we get? We get the point from which our domain is started. So x is greater than and equals to -2. So -2 is the first point from which our domain is started. And when we talk about the range of our function, simply you just put this values of domain in the function, put x is equals to -2. What you get? F of -2 is equals to -2 plus 2 under root, this is equals to 0. So our range is our range is we can say f of x is positive for all other values of x in the given domain. So range of this function is equals to 0 to infinity. But these are the domain and range of our original function of or f of x, where we have to find the domain and range of our inverse function. So by definition of inverse function, by definition of inverse function, what we have? We have domain of our inverse function. Domain of our inverse function is the range of our original function. Means domain of f is -2 to infinity, and range of our function is from 0 to infinity. So the range of our function become the domain of our inverse function 0 to infinity, and the range of our inverse function is the domain of our original function, right? This is the domain, this is the range. And by doing the same calculations, same steps, you can solve the rest of questions. And if you have any problem, you can WhatsApp me. Thank you very much.